Hello students and welcome back. So now we are going to talk about one more type of combinational circuit, and that is comparator. We are going to talk about 1-bit comparator in this video. So we are going to learn about what is a comparator, how to design a 1-bit comparator, and we obtain the Boolean expressions and logic diagram for 1-bit comparator. Now when we have two numbers, either they are decimal or binary or hexadecimal, we can always compare them with each other in terms of their magnitude. Whenever we do that, there are the possibilities of three possible outcomes. Either the first number is greater, equal, or smaller than the second number. So these are the three outcomes that we have when we compare two numbers. So let us look at the comparison. So I have two numbers A and B. So therefore I have four cases 0, 0, 0, 1, 1, 0, 1, 1. When A and B both are 0, they are equal to each other. So there are three possible outputs: G for greater, E for equal, S for smaller. So here G is 0 and S is 0 and E is 1 because they are equal. When we have 0 and 1, that means A is smaller than B. So S is 1 in this case. When I say 1, 0 case, then A is greater than B. So G is 1, other two outputs are 0. And when we have 1, 1, then again E is 1 and other two outputs are 0. Now when we look at this truth table, we see that G is basically A, B bar, E is AB plus A bar B bar, which is actually XNOR of A and B, and S is A bar B. So we get the Boolean expressions as well. So now we can very easily construct the logic diagram. We have a block diagram where A and B are inputs and there are three outputs, and these are the logic diagram based on the Boolean expressions that we have just discussed. So now the implementation is very easy. We can use data flow modeling and write three expressions, three assignments for G, E and S. We can also use if-else statement. We can also use case statements. These are all possibilities to design this 1-bit comparator. So let us check one of them using Vivado now. So we have our module ready. Comparator 1-bit, A and B are the inputs, G, E, S are the outputs. So we simply say assign G is equal to, so what was G? G was basically A, B bar. So A and with complement of B. Then we say assign E equal to A XNOR B, right? Then we say assign S equal to complement of A and with B. So that's all about the coding part. Now we can generate the schematic for this circuit. So the schematic is ready now. You can see XNOR of A and B is E, A B bar is G, and A bar B is S. So this is all fine. Let us check the simulations as well. The simulations are ready, and we can see when it is 0, 0, then E is 1. When it is 1, 1, then also E is 1. For 1, 0, greater is 1, and for 0, 1, smaller is 1, and this will repeat. So now we have successfully implemented a 1-bit comparator. So students, once we have designed 1-bit comparator, let us design a slightly complex one. So we are going to talk about a 4-bit comparator design in our next video. Keep learning. Thank you.